Video you will learn how fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules, and the longer the molecule, the greater the intermolecular force. As you can see here, the small molecules have weaker intermolecular forces, and so will require less energy to break them apart and turn them into a gas. They have a lower boiling point. The longer molecules have greater intermolecular forces. More energy is required, a higher temperature will be needed to evaporate these molecules. They have a higher boiling point. Now we understand how chain length is related to the boiling point of a molecule. Let us look at how this method works. As you can see, crude oil is heated up to a high temperature outside of the fractionating column. The hot crude oil, now mostly in vapour form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some long chain molecules with high boiling points begin to condense back into a liquid. These are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapour, and eventually the vapours get too cool, condense, and are collected as liquids in the trays. Small molecules have low boiling points, and so condense much higher in the column, where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Each fraction has some important uses. Some examples of fractions are petrol, useful as a fuel for cars; naphtha, used in the manufacture of chemicals; kerosene as aircraft fuel; diesel oil, used as fuels for vans, cars and lorries; and bitumen, a mixture of large chain hydrocarbons used to lay roads. Now, at the end of this video, you should understand that crude oil is a mixture of important hydrocarbons, and that fractional distillation is the method used to separate crude oil into useful fractions with similar boiling point. You should understand that small chain molecules are collected at the top of the column since they have lower boiling points, and larger chain molecules are collected further down the column as these have higher boiling points.